To add or subtract rational expressions with like denominators, first let's check to make sure our denominators are the same. Since they are the same, we can just add our numerators. 12 minus 2 over the denominator, the common denominator of 5x. 12 minus 2 is 10 over 5x. And we can reduce that just like we always know to do. 5 goes into 10 2 times. So we have 2 over x is our final answer. These work just the same way. You're used to working a problem like this. If you say 1/2 plus 3/2, you know that if the denominators are the same, all you do is add the numerators. 3 plus 1 is 4/2, and of course we would reduce that to 2. It works the same way when you have binomials here. If the binomials are the same, then all we have to do is add the numerators. So 3x plus 1 over our denominator of 2x plus 5. This next one works just a little bit differently because now we have this negative right here, and we remember that we have to distribute this negative to everything here. So I'm going to put parentheses around there so you'll remember to distribute that negative here. But our denominators are the same, so we write our denominator one time and add the numerator. That's 2x plus 1. Then we have minus x and plus 4. Now add your like terms in the numerator. So we have 2x minus x is x. 1 plus 4 is 5. And our denominator is x plus 5. And now when we get to this point, now we can see that the top and the bottom are exactly the same. And we know that when the top and bottom are exactly the same, that reduces to 1. Unlike denominators are a little bit different. Well, just like we know how to add and subtract fractions that have unlike denominators, we find a denominator, a common denominator. So 4 plus 5 is 20. 4 times 5 is 20. So our common denominator is 20. 4 goes into 25 times. 5 times 3 is 15. These two fractions are equal. 5 goes into 24 times. 4 times 1 is 4. These two fractions are equal. So now just add your numerators and write your denominator one time. Okay, it works the same way with rational expressions when we have unlike denominators. These are the steps we're going to follow. You can stop the recording now, copy these down, and then come back and work the problems with me. Okay, so let's see what we've got. The first step is to factor each one of our terms. Now these aren't rational expressions. We're just going to use these to practice getting our least common multiple of these expressions. So the first step is to factor. We can take a 5 out. We're left with x squared minus 9. X squared minus 9 factors with x minus 3 and x plus 3. Let's factor this one now. We can take out a 4. That leaves us with x squared plus 6x plus 9. And this will factor with x plus 3 times x plus 3. Whenever we see two of the same, let's rewrite it like this, x plus 3 squared. Now we're going to look at this factored expression and this factored expression and see if we can find the least common multiple of these. We need one of each kind of factor. So I'll look at my numbers first. I have a 5 and a 4. I need both of those. So our LCM is going to be 5 times 4. I see that I have an x minus 3. I need one of each kind of factor. I don't have an x minus 3 over here, so I'll write our x minus 3 down. Now I have an x plus 3 here and an x plus 3 squared here. I use the one with the highest degree. So I'm going to write x plus 3 squared. I don't need to write this one down because I have the one with the highest degree. This is my LCM right here, which can also be written like this, and we're just going to leave it all factored out as we're working with it. There's our LCM right there. Okay, let's try this one. This expression does not factor. We're going to leave it just the way it is, 5x cubed. Over here, we can take out a 5 and we can take out an x, and that's going to leave us with 2x minus 3. So let's see what our LCM is going to be. We need one of each kind of factor. I have a 5 here and a 5 here. Let's take a 5. I don't have to write this other 5 down. I have an x cubed and an x. I take the x with the highest degree. So I take an x cubed. I don't have to write this x here. Now I need this factor because I need one of every kind of factor. And there is my LCM right there. Let's see how it works when we're simplifying. The instructions for this problem would be to simplify, which is really just to add. So the first thing we want to do is factor our denominators. This one doesn't factor. We're going to leave it just like it is. This one factors by taking out a 5x, and we're left with x minus 2. I'm going to mark that out because this is the factored term. I can go ahead and mark that one out there too. So let's see what the LCM is going to be. I need one of each kind of factor. Here's a 10. Here's a 5. If we were doing this with a regular fraction, you would know that we need just the 10 and not the 5, because isn't 10 5 times 2? So if it includes a 5, if it's a multiple of 5, we only need the 10. We don't need this 5. X squared or x, we need the x squared. And we need this factor, x minus 2. There's our LCM. So we need to change each one of our expressions to have the same denominator, or the LCM. So I look to see what's different between this denominator and the LCM. Well, the missing factor is x minus 2. So I'm going to multiply the denominator by x minus 2 so that I can make it look like the LCM. If I multiply the bottom by that, then I have to multiply the top. All right, let's look at the other side. It has a 5x, but the LCM has a 10x squared. So I'm missing a 2x. So if I multiply the bottom by 2x to make the two denominators equal, then I'm going to multiply the top by 2x. So let's see what all I have now. My LCM is always going to be my denominator. And now the numerator, I'm going to distribute or multiply and then add. This is 3 times x minus 2. And on this side I have plus 2x times 2x. Now I'm going to distribute and combine like terms. That gives me 3x minus 6 plus 4x squared over the denominator. Leave it all factored out. To write it correctly, we're going to put it in order. So I write my 4x squared first, plus the 3x, minus the 6, and I see that I cannot factor that. I cannot reduce anything, so this is my final answer. Let's see how number 7 is going to work. I'll get you started on it, and then you finish it and come back and check your answer. First thing we want to do is factor the denominators. So this one factors with x minus 4 and x plus 3. On this side, I factor out a 12, and I'm left with x minus 3. Let's decide what the LCM is going to be. I need 1. How about x minus 4? We're going to decide what our common denominator is. We need one of each kind, so I need the 12. I need the x minus 4, and I need the x plus 3. That's my LCM. You do the steps that we just did, multiplying the top and the bottom by the missing factor, and see if you can get the final answer. Let's see how number 8 works, because now remember I have a negative right here that needs to be distributed here. So let's see how that'll work. First of all, I'm going to factor my denominators. That gives me x minus 5 and x plus 1 on this side. I decide on my LCM. I need the 3, I need an x minus 5, and I need the x plus 1. So now, what's missing from each expression? What's missing from this one is an x plus 1. So I'll multiply the bottom by x plus 1 and the numerator by x plus 1. Let's look at the other expression. I have an x minus 5, I have an x plus 1, I need a 3, so I'm going to multiply this side by 3 over 3. Okay, my LCM is always the denominator. And now let's see what I'll do with the numerator. This is x times x plus 1 minus 3 times 2x plus 2. Let's see what we've got. X squared plus x minus 6x minus 6, all over my denominator. And now I'm going to combine my like terms here, so I have x squared minus 5x minus 6, and my denominator. Well, now I see I've got something that I could factor right here. Let's see if I factor it. I can factor it with an x minus 6 and an x plus 1. Alright, this same denominator. Now I see that I have some common factors here. X plus 1 over x plus 1 reduces to 1. So my final answer is x minus 6 over 3 times x minus 5. There's my final answer right there. I'll get you started on number 9, and then you see if you can finish it. First step, we factor the denominator. This factors with x plus 2 squared. This factors with x minus 2, x plus 2. Our LCM is, remember, we take the factor that has the highest degree, so we take x plus 2 squared times the x minus 2. And now let's deal with each expression to see how we need to change it. You do the rest of the steps by yourself, and then come back and check your answer. Did you find that this one had something tricky in it? For one thing, this x minus 2 has to be FOILed with this x plus 1. So let's write the denominator one time. X plus 2 squared times x minus 2. We've got to multiply the top of the first one, x minus 2 times x plus 1. That's got to be FOILed. Then we have minus 6 times, the missing factor over here was the x plus 2. So now let's see what we have. We're going to FOIL, so we have x squared minus x minus 2 minus 6x minus 12. Our denominator stays the same. And now we combine our like terms. In the numerator, we have x squared minus 7x minus 14. Denominator stays the same. I see that I cannot factor this, so my final answer is that. Now, what if you wanted to make sure that your answer was correct? You can check it. If you will, check with a 0. Plug a 0 in for x in the original, and plug a 0 in for x in your answer. Then evaluate that and see if they're equal.